All right, so check this out. We've got what looks like a pretty standard university course syllabus. But what if I told you this isn't just for a class? This is actually a blueprint, a detailed map that explains the entire architecture of the internet and how our digital world really works. I mean, think about it. You do it a dozen, maybe 100 times a day. You type in a website, hit enter, and poof, the page just appears. It feels instantaneous, like magic. But have you ever stopped to wonder what actually happens in that split second between your finger hitting the key and the page loading? Well, it's definitely not magic. It's an incredibly complex but also beautifully organized journey that your simple request goes on. And this course syllabus, this is the exact map we're going to use to follow that journey from your keyboard all the way to a server halfway across the world and back again. So let's start with the big idea. This university guide reveals the fundamental secret of how all our devices talk to each other, not just in the same room, but across the entire planet. Now, you can skim most of this, but there is one key phrase here that is everything. Layered architectures. Seriously, that is the single most important concept to grasp. The whole internet, every email, every video, every single thing, is built on this idea of layers. It is the secret sauce that lets the internet function and evolve without completely falling apart. So let's take that journey through the layers. The best way to think of it is like a high-tech postal service. Each layer has one very specific job to do to get your message packaged up and ready for its trip. See, a layered architecture takes this massive, overwhelming task of sending data across the world and just breaks it into small, manageable chunks. Your request doesn't just zap from point A to point B. It gets carefully packaged, addressed, and sent down through a stack of layers on your computer. And then it gets unpacked in the reverse order on the other side. The absolute genius of this is that you can innovate on one layer, like inventing faster Wi-Fi, without having to reinvent the entire internet from scratch. And this is that stack. We start at the top, the application layer. That's you in your browser using HTTP. Your request gets handed down to the transport layer, which is kind of like the mailroom. It chops the data into little packets. Next, the network layer slaps the final destination on it, the IP address, the unique street address for every device online. Then, the data link layer handles the local trip, like getting from your computer to your router. And finally, you hit the physical layer, where it all becomes real, just electrical signals in a wire or radio waves flying through the air. Now, for this to work, each of those layers has to follow a super strict set of rules, or protocols. These are basically the rules of the road for the information superhighway. Let's look at a few that our syllabus points out. So, back in that mailroom, the transport layer, you have a big choice, TCP or UDP. TCP is like sending a package with a tracking number and requiring a signature. It's a little slower, but you are 100% sure every single piece gets there in the right order. That's for things like emails. Then there's UDP. That's like just tossing a postcard in the mailbox. It's way faster, but if a bit gets lost along the way, oh well. Perfect for live video streaming, where speed is way more important than perfection. Then you've got the addresses themselves. For decades, we used IPv4, which gave us about 4 billion unique addresses. Sounds like a lot, right? Well, with every phone, laptop, and smart fridge needing one, we ran out. We completely exhausted the supply. That's why the world is moving to IPv6, which gives us, well, a number so massive you literally can't even say it. We are not going to run out of those. Ever. And how does your data know which way to go? Well, it uses routing algorithms. They're basically the GPS of the internet. Our syllabus map shows us there are a few different kinds. You've got older, simpler ones like RIP, which are fine for small office networks. You have much smarter ones like OSPF that big companies use. And then you have the big one, BGP, the Border Gateway Protocol. This is the absolute powerhouse that connects the massive networks together and literally holds the entire global internet in one piece. Okay, I know, that's a ton of theory. But what makes this blueprint so amazing is seeing how it all comes to life in the real world. This guide shows us how students take all these abstract ideas and actually use them to build things. I mean, how cool is this? Students aren't just reading about protocols. They're using special software to design and build a virtual smart home. They're actually applying these concepts to connect to virtual lights, sensors, and appliances and make them all talk to each other. That's when theory gets real. And it goes way beyond that. The practical labs here cover the whole shebang.
mastering essential tools like ping, getting hands-on with real switches and routers, setting up core internet services like DNS, the internet's phone book that turns website names into numbers. They're learning the routing protocols, they're building security rules. This is the real training ground.
So, after all the theory and all the practice, what do you actually walk away with? What skills do you really master? Let's just translate the academic jargon into what it actually means. First, you become an architect. You learn how to look at an empty office space and design a fully functioning, efficient network completely from scratch. You also become a detective, because when the internet breaks, and trust me, it always breaks, you'll know how to dive in, analyze the problem, pinpoint the exact cause, and get everything back online. You learn to be a traffic controller. You understand how to manage the unbelievable flow of data zipping around the planet, making sure everything gets where it needs to go without causing a massive digital traffic jam. And finally, you learn to look ahead. This isn't just about cables anymore. It's about understanding Wi-Fi, cellular, Bluetooth, all the wireless tech that connects billions of devices and is shaping the future of how we communicate. So that simple university handout ended up being a blueprint for an entire world, all built on a foundation of layers. From the physical wires all the way up to the apps on your phone, each layer has its own job. It really makes you wonder, as we move forward with AI, with virtual reality, with technology we can't even imagine yet, what's the next layer going to be?